You're right, Kate. All right, welcome to lesson 25.
So. The lesson is called
Congruence.
Congruent
Criteria.
Criteria for Triangles
A.
AAS and HL.
Very good.
And getting a plus.
All right.
I'll be back later.
All right, so we're going to take a look at writing a proof. Okay. So let's just go over this one first, just a quick review. So try this one on your own, okay? And then we'll go together and see how far you can get.
I can get really far. I can go to page 107.
Okay. So if you had a chance to try it on your own, awesome. If not, let's finish up our statements and reasons here. Okay, remember when you're done, label everything that's marked congruent in the given. So DE congruent to DG, and then EF congruent to FG. We're trying to show that DF is the angle bisector of EDG. We haven't covered this yet, so we're not going to do this just yet, okay? So instead, I just want you to show that triangle, all right, DEF is congruent to triangle DFG. We'll come back and do this question when we get to what's called CPCTC. All right, so how are you going to get these two triangles congruent? So hopefully you recognize that you don't have any keywords in the given, okay? So if we look at our picture, we see that shared side in the middle. So you should have said that DF is equal to DF. That's reflexive. And then do we have enough to get the triangles congruent? The answer is yes. So triangle DEF is congruent to triangle DF. Oh, it's DEF. This should be DGF then. So careful with that. Remember we talked about that yesterday, making sure that we use the correct order so the corresponding points are in the same position here. And this would be side, side, side. You're into side, side, side. Okay, so I did mention what's called CPCTC. That means that as these two triangles are congruent, all their corresponding parts are also congruent. So that means that angle E is congruent to angle G, angle EDF and GDF and GFD and EFG. So if we were going to say that this was an angle bisector of EDG, we would want to get these two angles here congruent. And we could do that, okay, with CPCTC. We can literally just write down CPCTC, okay? All right, and then all we're going to do now is say that angle EDF, that was right, is congruent to angle GDF. And then once I know that these two angles are congruent, that's enough to say that this is the bisector. So this is how we use CPCTC. We're not going to do this today, but just wondering if you're wondering how we would get there. Okay? And then we would just say DF, right, is the angle bisector of angle EDG. And we would just say the bisector cuts the angle into two, not the word two equal parts. Okay? Now, tomorrow, I'm going to be joining you guys live to do a little review with you guys. So we're going to be using the Teams link tomorrow. So make sure you're around, and if things change, I'll let you know, but that's the plan right now. Okay, so we're going to move on to the next page here. We're going to talk about what's called the angle side angle congruence. We've kind of talked about this before. Okay, we're also going to talk about the other criteria that we might think of, right? If you think of all the other combinations of S's and A's, right? We have angle, angle, side, left. We have side, side, angle, left, okay? Also angle, side, side. We've talked about that before, the donkey theorem. And angle, 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 okay? So angle, side, angle is a congruency theorem Because if I knew these two angles, right, these two sets of angles in the triangle, I would be able to get this third angle, the measure, because they all add to 180 degrees.
In fact, if it 180 degrees, if it goes next 180 degrees, it will go 181, 181 degrees.
All right. So, all right. So here we go. So once again, if these angles are equal, now we have the situation where because we knew these two angles, we were able to get the third, and this is actually just an extension of angle side angle. Okay. So the reason we can use angle side is because we would be able to get the third angle to get angle side angle. So it's just an extension of that criteria. Okay. All right. The last one is the hypotenuse leg. Okay. So once again, when you have a right triangle, okay, with one of the legs and the hypotenuse is congruent. So in a right triangle, okay, in a right triangle. All right, the side that's across from the right angle, like if you make this an arrow, okay, where the right angle symbol is, it always points to the hypotenuse. So you need this side and one of these other two sides, which are called the legs. Okay, the legs. All right. So that's what we're going to be seeing when we do a triangle. We got to have the hypotenuse and one of these two legs in both triangles, corresponding leg to be congruent. So notice here, okay, here's the right angles where angle B and B prime are. So that makes this side the hypotenuse. And these two sides are the corresponding legs. Okay, they're the corresponding legs. They would map onto each other when we do the reflection. Okay, so since these are congruent, we would be able to do a congruency theorem using HL. Now, what you need to do is, in order to use HL, okay, in your proof, all right, number one, okay, we have to state that we have a right triangle. There is a right triangle, okay? You're normally going to get either a right angle or a 90-degree angle in your proof, okay? Right or, not of. A right or a 90-degree angle somewhere, okay? The reason is just going to be that a triangle with and it's either going to be a right or 90-degree angle, okay, is a right triangle. Or if you want to phrase it differently, right, say a right triangle has a 90-degree angle, it's up to you, one of those two things, okay? All right. And then once this is done, then you can use HL, okay? So step 2 is to get the hypotenuses and corresponding legs congruent. So make sure we have a right angle, okay? That has to happen first. Get yourself a right angle, or sorry, right triangle, not a right angle, okay? So there has to be a statement that says triangle ABC, like ABC is a right triangle, okay? Then we have to get the hypotenuses and the corresponding legs to be congruent. Once we have that happen, we can use HL. So you're going to see that today as we work along here. Okay, we're going to skip this part, but remember we talked about like if you wanted to draw this line in for yourself, okay, and then there's talking about the fact that you can reflect this over and create in congruent triangles here. So like these triangles are congruent, those triangles are congruent, that type of thing. Okay, so what other thing that's important here? All right, we're going to get to the proofs and the practice. What criteria do not count? Do not count. There's two of them, right? We talked about side-side angle or angle side-side, right? Can't use this one. This is the donkey theorem. And angle, angle, angle. So here's the donkey theorem, okay? Here's the donkey theorem. All right. Notice these two triangles both have an 11-degree angle or side, a side of 11 and 9, and a 23-degree angle in here. But they're not congruent to each other, okay? If you put the two triangles together, this is what happens. We get this option. So we get this going on, where this side is 9 or this side is 9. It's like you're swinging this side through, okay, like on a pendulum, and it's creating two intersection points here, okay? So depending on the length of this side, right, when we swing it like a pendulum, we could end up hitting this just at one point. We might not hit it at all. We might hit it twice, right? So there, in your algebra 2, when we talk about the law of sines, you can actually figure out, okay, if you're going to get 1, 2, or 3 triangles. Not going to do it here though. So all we need to know is the donkey theorem cannot guarantee triangle congruence. You could have 2 triangles with those values, okay? The other one is the angle, angle, angle. We talked about angle, 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 right? When you do a dilation, we get the angles congruent, but the sides are not congruent, okay? So all the triangle congruency theorems that we can use are the side, 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 angle, side, angle, side, angle, 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 side, also known as side angle angle. So you can do it either order, okay? And HL, hypotenuse leg. Those are the 5. The ones that don't work are the donkey theorem, okay? So angle, side, side. Don't be writing bad words here, okay? Or side, side angle. All right. Got it? Okay, can't do that. Right? And angle, angle, angle also does not work. Okay? Does not work. Can't do it. Okay? So no donkey theorems and no AAAs. All right, let's do an example. Let's take a look at number 1. So in number 1, we know that BC is perpendicular to CD. That's what this upside down T means. That's a key word. And we know that these two angles are congruent. All right, so let's fill in our T-chart statements and givens. Okay, so now that we fill them in, we can go ahead and mark angle 1 outside here, congruent to angle 2. And the problem with this is that it's not inside our triangle, it's on the outside. Okay, so we're going to need to use these two angles to get these two angles in here congruent. We're going to need to get these angles congruent. Okay, we talked about how to do this before, right? With the fact that these angles make 180 degrees. Okay, the other thing we have is we have keywords here. So let's take a look at those keywords first. Perpendicular means that we have 90-degree angles. All right, so we're going to do this in one step, right? We're going to do this in one step. We're going to say angle C and angle A are congruent. Okay, and the reason we're going to do this is we're going to write down this symbol, which means perpendicular. Perpendicular lines make congruent 90-degree angles. Okay, and what I actually am going to do is I'm going to change this congruent symbol. We're going to write it a little bit differently. We're going to write equals and then equals 90. So we're going to write angle C equals angle A, which equals 90. So we're saying not only do these angles equal 90, they're equal to each other. Okay, so that's going to be the way we write this moving forward. All right, now we need something else congruent here. We need something else congruent, right? So if we look at the picture, we talked about the fact that we have to get these angles congruent. So let's work on that. So let's call this angle 3, and we'll put a 4 here. We can go ahead and label these for ourselves. So now I can do angle 1 plus angle 3 is equal to 180, and angle 2 plus angle 4 is equal to 180. Okay, and remember we talked about like we could write stuff like supplementary angles or a linear pair of angles. Add to 180 degrees. So whatever you want to put down here is totally fine. I'm using supplementary angles, but if you put linear pair or straight line, that's awesome. Okay, the lamp wouldn't work. But now, since these two things are equal to 180, we can
Equal.
yeah, they're equal. Very good. So angle 1 plus angle 3 is going to equal angle 2 plus
Something
angle 4. All right. So this that's called the perpendicular symbol.
Oh.
This is called the substitution.
Is there a short name for that perpendicular symbol?
It's not.
There is no short name for it?
No short name for it. This is just a symbol that represents that word. Okay? Substitution. All right? And then we're going to all right. And then we're going to get rid of the two angles that are equal here in that statement, which is 1 and 2. So we're going to subtract them away. So we're going to get angle 3 equal to angle 4. This is the subtraction property of equality. 2 more steps, guys. All right. Now, the problem we have is we only have 2 angles congruent. So we can't do angle, 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 right? Remember, that's out. So we can either do angle, side angle, or angle, angle, side. Those are the only things we can do. So is there a way for us to get these two sides or those two sides equal, or the side that's over here? And the option would be the side that's right here, right? The shared side in between. So for 6, and then 7 is going to be our proof statement. So 6 is going to be BD is congruent to BD. We'll add on top there. That's the reflexive property. And then for number 7 here, we're going to make sure we write our proof statement. So triangle BCD is congruent to triangle BAD. And that we already talked about is going to be angle, angle, side. Now the reason it's angle, angle, side and not angle, side, angle is because we have the angle, angle. This would need to be the side to do angle, side, angle. It's not. It's this side. So this is angle, angle, side. It's not in between. Okay? And you could also put down side, angle, angle. That's the same theorem. It's just written backwards. Okay? So there's angle, angle, side. So the next one we're going to do is going to be a hypotenuse leg. So remember the process, right? Number 1, we have to get some sort of a 90-degree angle or a right angle. Okay? We're going to make sure we say it's a right triangle. Okay? And then we can go ahead and use HL, but we have to get a hypotenuse and a leg in both triangles congruent. So let's do it. So go ahead and fill in your T-chart, statements and reasons. Pause it now, finish that. Okay, so once again, mark down anything we know is congruent. So we know that A, B, and CD are congruent, and we have those key words, the key symbols of perpendicular again. All right, so we know that AB is congruent to CD. Okay, and then where AD and BD meet. So AD and BD meet right here. We're going to get a 90-degree angle. And where BC and BD meet right here, we're going to get another 90-degree angle. So remember what we're going to say. Now we can't say angle B because there's more than one angle B here. So we got to be specific. So we're going to say angle ADB equals angle DBC equals 90. Okay, when we want to do that perpendicular statement, that's what we're going to write. And then we're going to write perpendicular lines make, this is important, congruent. Make sure you don't forget this, okay? Congruent or equal 90-degree angles. All right, now we have, if you look at the triangles, right? These are the hypotenuses. We have those congruent. We have to get either this leg or, right, these two legs or this leg. Oh, hey, look at that, another shared side. So we can get this leg and both congruent. Okay, so we're going to go ahead and say that BD is congruent to BD. That's reflexive. And then let's take a look at our checklist over here on the right. So we got a 90-degree angle, right? We got 90-degree angles, so they're equal, right? We've got hypotenuses and legs. The only thing we haven't done is said we have a right triangle. So we need to say that triangles, right? We can just say triangle ADB and triangle CBD are right triangles. The reason we're saying this is because in order to use HL, you have to have a right triangle first. We have to make that statement, okay? Seems a little ridiculous, but we need to say it. And then how do we know it, right? Because we have 90-degree angles, okay? So now we can say a triangle with a 90-degree angle is a right triangle, okay? Now, we've done the checklist. We got all three things done. So now we can go ahead and use HL. So now I can say that triangle ADB is congruent to triangle CBD. So notice, A is the same as C, B was the same as D. Those are in the right order, okay? So D and B, B and D, good to go. So now we're going to go ahead and go down with 5 here. And we're going to write HL is congruent to HL. Okay, let's do one more like this in the problem set. Let's take a look at number 1. Okay, we're going to skip the first putting in the givens. We're going to skip that for now because we might need a little bit of room. And I'm choosing this problem specifically, all right? I don't even know if this is an HL question, but we're going to do this one anyways because it's got something I like in it. So number 1 we know is the givens. We're going to skip that, okay? So let's go through what do we normally do, right? Looking for keywords. We got perpendicular, we got a parallel here, and we know that these two are equal. So let's mark, we got AF and DC are equal. Notice that these are not, right, sides in the triangles. These are not sides in the triangle. So we might need to do something with them now. But we do have perpendicular. So let's use that. So AB and BC meet, okay, and form that 90-degree angle. And DE and EF meet and form that 90-degree angle. So we can say angle B, because we can use it because it's only one angle at B, equals angle E, which equals 90. Perpendicular lines make, right, equal 90-degree angles. Okay, and we also know, right, we can mark it down that BC is parallel to EF. Remember what we love to look for when we see parallel lines? We love looking for that Z. We got it right there. So we know that these two angles, we can't say at F because there's two angle F, so EFD, okay? Angle EFD is congruent to BCA. BCA. Remember, this is a little long, annoying reason, right? Two parallel lines cut by a transversal. Okay, alternate interior angles are congruent. Okay. Now we need to get something else equal. We have two angles. So if you look at the triangle, right, we only know that this angle and this angle, and we have like a portion of this side. So we don't have enough to get congruent. But if you notice, right, this triangle right here is made up of, right, AF And then this extra piece makes up this whole side, right? FC. And this side is CD, and then the same extra piece here, right, makes this side FD. So if we can just combine, like add FC to both of these, we would have a side, right? Okay, this is kind of like the opposite of doing the subtraction, right? If we just subtracted this away, we would get left with these two pieces. Now we want to add that piece on, okay? So here's the strategy. We first need to say, because what we want to do, okay, here's what we want to do for step 5. We want to say AF plus FC is equal to CD plus FC. So we want to add this piece on to both sides, okay? But before we do that, we actually have to say that FC is equal to FC. And remember, our given was that AF was equal to DC, so we're just adding on, right, FC to both sides. So we have to say it's equal, we have to know it's equal in order to use the addition property of equality. So we're going to do reflexive property first. I know it sounds a little ridiculous. Okay, and we'll do some more of these on Monday as well. Tomorrow together, virtually, and then on Monday. All right, so this is the addition property of equality. Okay, so let's go to number 6. Okay, so Kate, what happens when we put together AF and FC? What does this whole side become? It becomes AC. It comes AC. So we're going to write AC here. And if we combine FC and CD, we get this whole thing, which is FCD or FD. The reason we're just taking this sum and replacing it with what it's equal to.
Could you write FCD?
You could, but we're just going to put FD.
If you want, you can write FCD, but for sure.
Nice. And this is just substitution. You can also call this segment addition, but substitution is kind of easy to remember there. And now we have this whole side, right, equal to this whole side. So now we have angle side. And now we can do our proof statement, okay? And then this is angle side, angle side, okay? Awesome. All right, so here's what I want you guys to do. I'm going to check this homework on Monday, okay? So make sure that this one is getting done, and I'm going to check it on Monday in your note packet, okay? Day 6 homework. We just did number 3, so you don't need to do number 3. We just did it together, okay? So you're just going to try these two right here. Try them on your own, and we're going to go over these together on Monday. I want you to see how far you can get on your own, okay? Right? So using HL, so remember, we want to get 90-degree angles, right? 90-degree angles, okay? A right triangle, a hypotenuse, and a leg. Congruent. So go through the checklist, make sure you go get all these things checked off, and then you can do HL, okay? And then this one should be nice and easy for you. This should just label out the figure and see if you can do this one on your own, okay? This one may be a little bit tougher, but you should be able to do 2. Don't need to do 3. All right, guys, remember, tomorrow for class, you're going to join me on Teams, okay? Sound good? All right, we will see you guys tomorrow. This homework, remember, once again for day 6, is due on Monday. Monday, people.
Hey!
All right, say goodbye, Kate.
Bye, and don't forget if you did.
Don't forget to see you tomorrow when they join the team.
Yeah, don't forget.
All right. We'll see you guys later.
Not yet.
Say bye. Bye. Bye.
Don't forget.
Bye.
Right.